Hello, everyone. Welcome again to our Carbonetic channel. Martin with you. Pleasure to meet as every week. Once again, our CEO, Mr. Brent Tolmie. Hi, Brent. How are you?
I'm well, thanks. How are you?
I'm good. I'm good. Been told that you're in a different forest today. You're around Banff area, a forest that you pretty well know.
Yeah, Rocky Mountain Forest, so a mix of beautiful spruce and pine and deciduous trees in Canmore, Alberta, which is just slightly east of Banff, right in the heart of the Rocky Mountains. And love the mountains, love the majesty of the Rockies, how they plunge up from nowhere, and just enjoying our time in Alberta. And of course, got to be in the trees. Got to be in the trees.
And it's going to be a subject of a future video as well regarding the condition actually of the forest, knowing that it's a national park, especially Banff area. But it doesn't mean that conservation as being, what it is, really improved the way that the forest works. But that we're gonna keep it for another video at one point. Today, I want to cover with you, Brent, technology. I know it is a subject that you really like, the forest and technology as well. In the previous videos, we covered who we were. We also covered who you are, where you come from, your expertise. We covered actually the carbon offset market. And today I want to show our viewers the technology that we are developing to be different than what the others are doing. So back to 2020, 2021, when we built the company and we started being Carbonetic, there's a fundamental reason why we started Carbonetic. Of course, our love of the forest, wanting to support actually our indigenous partners, communities. And at the end of the day, we saw that we had issues in the carbon offset market, lack of transparency, lack of integrity in multiple different kind of products which were offered to the market. And this is the main thing that we wanted to solve as problem solving, right? So before that, I showed the technology itself. Brent, any comments you want to add on the mission that we have regarding developing that transparency and integrity?
Yeah, I think everything you said is true. We obviously agree. I would point out to our subscribers and our listeners that we did look at the carbon market and how it was performing, particularly in improved forest management or avoided conversion projects. And we just saw a lot of waste, fraud, and abuse. And not every project, of course, and the majority of them are just fine. But what we found was a lack of data confirmation that those projects were performing as advertised, that there wasn't enough inventory sampling in type specific to that ecosystem, or they were relying on examples from outside of that jurisdiction, or they were just using certain techniques to juice up the amount of credits that they could sell from that project. And so when we looked at designing a better mousetrap, essentially, our goal was to take all of that information and address it. And we felt that we could address it through the use of technology so that our credits would have trust, transparency, and reliability. And I think that those are the markers of the credit that we've designed. And of course, we adhere to those protocols we discussed last week. FCOP, Verra, ACR, because all that math was agreed to. But we can go one step further in taking extremely in-depth sample programs. We can collect a lot more information than is required by those standards. We can do better analysis. We can take more samples. We can have a better understanding of ecotyping, of biodiversity, all of those things. And then we can automate that process through technology so that we're not just looking at those samples once every 2, 3, 4, or even 5 years in some cases, but instead we can update that information on a somewhat iterative basis. And then one step further, we can actually link that information to the person who's buying the credit. And that's where trust, transparency, and reliability really, where the rubber meets the road. So if I'm the CEO of Shell Oil or CN Rail or internationally Total or somebody of that nature, Equinor, I can demonstrate to you that the credits we bought, that we spent, investor money on oil and gas, energy returns, transportation returns, whoever's buying, that we can show you this is the exact forest that we've de facto adopted, sponsored, and this change is real, it's materializable, it's tracking, and to be able to demonstrate that to your shareholders, so that it's not just this ESG CSR commitment that's nebulous and a bit of greenwashing in some cases, frankly, but that this is actually about creating real change. It's about improving a real forest and then tracking that and being able to demonstrate that through an app. And so that's really where we've gone, a combination of remote sensing and then getting that data in a usable format into the hands of the people who are trusting us with their purchases on credits.
So a lot of people would argue, Brent, why we are not just relying on GPS or relying on the initial mapping, which has been done, through history. Why do we want to push further and really create what we call internally a digital twin of the forest, right? So we have the capacity with technology that we will show with the demo here in a few minutes, that we can actually take a physical asset, turn it into digital. And the other question will be, why does it help? Really, of course, transparency and integrity, I got that, but also we can model and rely, if I'm not mistaken, on that technology that we can actually attack the forest, raise the temperature, lower the temperature in a digital format, and from there see how the forest will react in the future. Mm-hmm. So there's really multiple components which are really interesting into what we are developing. But first, why people argue about the quality of GPS and mapping first, and why we go further?
Yeah, I think so. GPS, global positioning, that gives you sort of an XYZ axis or an XY axis of where you are on the planet. So no argument with GPS. We see a lot of projects, though, using GPS and satellite together. And the problem with satellite, of course, is that the resolution is very low. So think back to, the 80s, where we used to catch a hockey game and you could barely see the puck moving because it was that old screen. And then we got into higher definition TVs where the puck would almost glitch. And now we're to the point where we just see it move seamlessly. And that's even on a $300 television. And so this idea about resolution is really what we're talking about. So if we did satellite-based imagery, we're getting blocky, pixelated chunks that are just not that accurate when it comes down to the complexity of an ecosystem and what's happening on the ground. So we designed a system based on remote sensing where we could fly very in-depth, very high resolution, high definition, top of the line imagery, and splice all that together, recognizing that not just one technology would do all. So grabbing photos from a satellite isn't enough. Grabbing LiDAR from a plane isn't enough. And I'll talk about the difference between drone-based LiDAR and air-flown LiDAR. One of the issues is the resolution. So of course, airplanes travel high and fast. So when they're shooting LiDAR, which is points of lasers that are hitting the ground to create a digital terrain map, essentially, plane-based LiDAR, 15 to 25 returns per square meter. So in that sort of 9-10 foot area, you're getting various pings. So that feels like a lot. When you're trying to stratify and collect information and make digital trees, it's not enough because you might be missing branches, you might be missing foliage, you might be missing the root structure. And yes, you can somewhat recreate the trunk of a tree, but if you think about putting a bucket in the middle of a square meter and then just dropping 15 or 20 different points around it, think about maybe jelly beans or something like that, and just dropping that around it, you're going to hit that bucket a few times. Now fast forward into low and slow drone-based LiDAR, and we're more around 900 or 1200 parts points per square meter. So we're going to get a lot of jelly beans in the bucket on that sense. And so it's just a way more data being collected. Yeah, and so these are our beautiful Skyfront drones, longest endurance hybrid gas helicopter or copter. And they're a tool to fly payloads. So specifically, we chose those drones because they have amazing range and they have the ability to pack a relatively heavy load, heavy in comparison to what drones can carry, for a very long distance. And they can stay in the air with our sensing loads for about 3 hours. So that means we can pick up hundreds of hectares of very granular data. So we would add that LiDAR, so those points per square meter. And we would also add high resolution photography or orthophotogrammetry. And with that, we can splice those images together as well as combine the LiDAR. So we're getting sort of that 2D version plus the 3D version. And then one step further, we actually add what's called true color or RGB, which gets into that, the whole theory of what we can see, how many colors we can see. So if you think about the average human, we can see about 100,000 different variations of color. If you're tetrachromatic, you can see about 3 times that, 300,000 perhaps. With computers, you can see an unlimited amount. So how green is the question. And if you're in agricultural science, for instance, if you have a crop full of lettuce, there might be a green mite that you can't detect with the human eye. But of course, that green mite is a different color green than the lettuce. And so that RGB or true color unit actually will pick up that mite. And then you'll be able to target that with pesticides or what have you, or perhaps that crop isn't functioning as advertised. And we can think about that when we walk through the forest and you look at trees in the winter where they're a bit of a duller color green because they're more or less dormant, and so they're not focusing a lot on growth, and so that affects sort of the shade or the variation or color. We can see that with hyperspectral analysis in a very granular fashion. So that allows us to get an indication of health and an indication of species. And we combine that with LiDAR, which gives us a structure not only of the ground, but also of the tree through allometric equations. And then we also apply those orthophotomosaics together. And that allows us to build a digital twin of that particular forest. And then because of the projects we work on are so large, we then take that information as well as all that other information that's known about the forest through satellite, through traditional vegetation resource information, scientific studies. We splice all that together and replicate that or regress that out of a larger area. And then as we fly more drone-based sensors, more remote sensing, we're able to update that information. One step further, all that information that we collect on a very granular basis, we also collate with boots on the ground. So when we establish a forest inventory plot to essentially measure the trees, take notes about what's there, what isn't there, classify all the layers of the forest. So dominant, the really well-performing trees, co-dominant, and then layer 3 and layer 4 trees. We actually have a center of that plot. And when we come over through with remote sensing, we have a target on that plot that the drone can then see. And we've got those coordinates GPS with very accurate GPS sensors. So we're actually able to recreate that plot that has been, all that handwork has been done. We've measured the bases of the trees. We've used lasers to measure the height of the tree. And then we splice that together with all the information that we've acquired from above. And that is the basis of our digital twin.
This is insane technology, right? And I'm pretty sure that the people now understand the extent of work which is required to get to that level of granularity into our research and our analysis. So I want you to comment actually now. I'm going to show the people what we are developing, and we've been working on it for what, 2 years plus. And so you can comment on exactly the way it works. So I think the first thing that the people have to understand is that it's an app integration. So where you can see the project size, where the projects are located. So I'm just gonna go, for the purpose of the video today, to spend less time and just showing exactly the fundamentals. And when we get to the technical part of all of these little screens that the people will see, you'll be able to comment, Brent. So the people can choose on the app exactly where they want to get the info from. So actually, there's two projects which has been built in the app. The Cascadena project we're working up north British Columbia, and the future project we're working on the Yukon project in Ross River. So this is the area where the customer can just push actually and look at where the project is located, and from there he will start his progress into the app, so we can see exactly the way it works. So I'll move it a little bit forward, so you can explain actually now from these two different projects how the app works and what's the benefit of it.
Yeah, so the idea is that any project that Carbon Ethic establishes will have access to this application if you're a credit purchaser. So we define a geographical boundary. So that's the boundaries that you see. And then all the little teardrops are plots where we've collected data from. And so you can click on those plots and they will actually lead you into exactly project area summary. So we're giving you a total area of the project, average sequestration rate. What does that mean? How much CO2 is this forest actually sucking out of the air? And then our offsets are different in that we can only claim for part of the sequestration that we either improve or prevent the loss of. And so again, the different equation. And then just giving the market some indication of how far the project has sold, how many credits are available, what's upcoming, all those good information points, as well as more detailed information points like biomass per hectare, which would include the above ground biomass, what you see from above, but also the root structure and all that carbon that's stored below in the root structures. So that's very neat. And then when you get into the layer, as Martin's advanced, you start to get the tree attributes. So height, species, diameter at breast height, which is at about 5 foot or breast height from a person when you're looking. So that's where you wrap your tape measure around to come up with that diameter, as well as age class. And then we would talk about things like so now we're down into the deep dark path, so we're actually identifying specific trees that have been surveyed, and we have granular information about that specific tree. So its coordinates, in the canopy spread, the height, and all of these pieces of information, again, have been picked up from above and below and spliced together to create this application. So an immense amount of work. It's beginning to be implemented in a full format now that we have actual plot data that we collected last fall. This is a visual representation of what the forest would look like. So taking that LiDAR imagery of the photo and the orthophoto mosaic and actually splicing it together and giving the user an actual visualization of the forest that they're sponsoring. So if you're buying an offset, go ahead.
Yeah, so they can identify exactly the plot where they bought their offsets from, and they can actually see exactly the location. They can see actually the landscape, if it's steep, if it's flat or such, with all different kind of, am I correct?
Yeah, that's where we're going to. And the idea is that you can not only match a buyer, exactly, you can not only match a buyer to a project, because a lot of companies like to, if you're drilling for oil off the coast of of Africa, pick a state, or say you're working in the DRC, well, then you would ideally be able to match your carbon emissions with a project in the DRC. And so this is the idea, is that if we can match this to companies that are active in northern BC and Yukon, but one step further, that we can actually match it to a specific area that perhaps maybe one day you'd come and visit to actually see that your credit purchases have made a difference. This is a representation of age class, or rather height. Again, this is a visualization. As we build this out, we're filling in the blanks. So some of the information's pretty easy to incorporate. Other pieces are tough, but this is what it will look like when it functions completely. It's pretty exciting.
Yeah, so the height is the different colors gives actually the different height of the trees in the area. And as we can see, the customer have the opportunity to watch either on 2 dimensions or in 3 dimensions as well. So it gives really a better scope of, the location, the tree heights. So you can see by different colors actually, and the amount of trees, which are related actually to the height and the color. So can you comment also on that picture, which represent, I guess, the height depending of the coloration?
Exactly. You've said it exactly. So we're giving a representation of how many trees are in that specific area, not only by type, but also in theory, we will match it not only with height, but also with species, because of course, different species grow at different rates. But this is the idea, and being able to identify canopy heights gives you an idea of what kind of forest that you're investing in. So, is this a younger age class? Is this an older age class? Is this really coming together quickly? Or, is it a very mature forest? So it gives the offsetter optionality in their purchases. If you want to purchase a very young forest and watch it sequester carbon for a long time, or if your interest is more aligned to the preservation of old growth or primary forests, then you can actually pick that.
So it's really like the other example that the people can see here is that you can also identify the species of trees depending on the color. So if it's spruce, pine, fir, or any other different kind, everything is quantified. This is really just not one tech, Brent, from my understanding. It's really stacking multiple different kind of technology all together to make sure that we can quantify actually, again, as granular as we can to get. That's pretty much it.
Yeah, ideally, we're not to the point where we're naming individual trees, but the idea is clear. If I as an individual and my family generate 10 metric tons of CO2 on an annual basis, wouldn't it be neat that we knew the specific forest, the specific region, the specific type, height, etc., and we could actually track the performance of those trees, that are offsetting our own individual carbon footprint as a family. That's very powerful. And for, let's say, a transportation company that has 100 trucks on the road and they're looking to do things different / better, they would actually have a specific area and say they had a keen love for spruce forest. Well, we could actually put them into a project that's predominantly spruce as opposed to balsam or pine or deciduous. So I think it's that optionality and that tie to granularity that can create trust, transparency, and reliability. And I think we've said it from day one, we're not looking for emitters as carbon offset purchasers. We're actually looking for partners. And we think that we create stronger partnerships, not only with our partnership with the Casca and our use of technology, but when we're meeting with people who are keenly interested in offsetting, being able to put, technology into their hands that demonstrates their commitment, we think is way more powerful. That connection from a nebulous concept like a carbon offset into actually, we're just sponsoring the growth of this forest, and we know that its performance is actually making up for the difference in our unreducible carbon footprint. That's the equation we're looking for, and that's where we think we'll find a big win.
I think that there's a need. Well, of course, we identified it years ago, but through the conversation and past conversations we had with multiple different potential partners, as you call them, it's obvious that they're looking for quality carbon offsets. They don't want to get caught with a, what do you call, like a unpinned grenade in your hands. That's something that you used actually last week as an analogy, which is, makes sense. They don't want to buy, bad offsets or offsets which don't do what they're supposed to do. And at the end of the day, the conversation which has been going for the last few years is that, yeah, we want to be active in the carbon offset market, but we also want to make sure that it's transparency and it's a good product. And maybe one word, I like when you're talking about, why we developed that tool, especially to support CEOs, board of directors, which sometimes are new in the carbon offset market. They don't know how to address, but they can prove actually their investors that they're doing good, right?
Yeah, I think that is the challenge, is that rather than buy this nebulous thing from a trader or something like that, it's connecting to the land. And we say that often at Carbon Ethic, that we want people to connect to the land. So this is the visual representation. And of course, if somebody said, well, hey, I want to verify this project, we can flood them with so much information, it would boggle their mind. And it's okay if they have a subject matter team, if they're active in the offset market, like some of these energy companies are. They have teams that understand the same things that we do. But if you're just an average business owner, or perhaps you have no link to the carbon market, supplying this data doesn't actually help people. So you need to build tools that are visual representation, or we like to call it handlebars. The easiest way to ride a bike is with handlebars. Without is a little tricky. And so we give the corporate market handlebars for their purchases, so they don't really have to spend too much time worrying that this will blow up in their face, but they've gotten some handlebars to drive around, and then just to demonstrate their commitment. And we think that's so key. If you are being asked to step up from an ESG perspective, or perhaps you have a tax liability that you're trying to reduce, rather than go through trying to understand it all, we'll put some technology in your hands that takes all that data that is available and puts it into, a very tactile format, so that you can show people what you're doing. And then if they have further questions, we'll go down the rabbit hole with them exploring the data. But most people just want it in a simple, easy to use format, similar to our smartphones. We want smart apps. There's a reason why people like certain applications over others, because it uncomplicates their access to that information. No different than why we love Google when it popped up, because it meant that we didn't have to search through the internet and all these different chat sites ourselves, but all that information was at our fingertips, but in an easy to use format. And that's really what we've sought to do with this application.
Well, thanks again for your time, Brent. And I think it's pretty interesting, especially for the people who like technology, to see where we can go to bring, again, transparency and integrity in such a market. If you need, more information about us, please visit our website at carbonethic.io. You can also, through our website, send us an email, and we'll be pleased to meet with you and discuss further down, how does it work and what we are doing and the greater good for the planet. Next week, Brent, we want to talk about our partners. And I think that something else which will be interesting down the road as well is, you mentioned today the boots on the ground work. That is something else that the people must be, in my opinion, educated on, to see how actually, and we have good pictures and videos of our team being boots on the ground and quantifying these trees and the way it works. I know it's part of your skill set and expertise, so that could be actually some content for the next 2-3 weeks. But next week, let's talk about our partners, the people who support and believe us, and that would be great as well. So thanks again, Brent. Always a pleasure. Talk to you.
Thank you.
See you. Bye-bye.